So my name is Mieszko Zieliński. I'm an AI lead at Epic Games. At Epic Games, ooh. And I'm responsible for changes to navigation system that were done in order to make deer run around in the GDC demo, which is a huge map. But yeah, let me take you through navigation journey. So first of all, let me tell you about Recast. Because Recast, it's a middleware. We're, well, kind of middleware. We're using to perform actual nav mesh generation. Okay, so is there anyone here that didn't hear about Recast before? Anyone? Okay, not many people. So that's because Recast is awesome. Because that's the best thing that happened to AI navigation in games since always. So forgive me, my phone. Oh, shut up. So Recast has been created a long time ago by Mikko Mononen. It's an awesome Finnish programmer. He used to be an AI lead at Crytek on the work on Crysis. And he created this thing, and he basically made it free. Just created it because he wanted, and he could, and he's awesome. So it's like really efficient, lightweight, nav mesh generation library you can just take and use. Basically, no strings attached. The only condition is that you remain Mikko's copyrights at the top of every file that you use, like a recast file. So it just works. You just take it and it works. Obviously, there's like some things you need to do to make it work exactly the way you want, but it's a super great basis. And there's a lot of companies that just took Recast source code and just included the sources in their own engine sources, basically, like that. And it's, like I said, it's an industry standard now, because there's almost no one that doesn't know about it. And there's no excuse for having anything worse than Recast, because Recast is free, and it's open source. So why would you have anything worse, right? At some point, actually, Epic invested their own resources into implementing a custom nav mesh, but we switched over to Recast at some point anyway. And at some point, Recast went away because Mikko went off to do some other things because he's a creative guy, not only a programmer. But he came back. He works somewhere else now. But Recast has been resurrected and is fully available at GitHub. So this is a Recast demo. That's a little program that comes along with Recast sources. And you can just take it, play around with it, and it shows, like, it has a lot of cool options. You can use the features and see the statistics, how much memory it takes, how fast it is. It's super fast. And it's pretty old. I mean, the Recast started a long time ago. This is a screenshot from Bulletstorm editor. We use Recast in Bulletstorm, and it's shipped like 4 years ago. That was actually the very first use of Recast in Unreal Engine. Since then, we've been using it, well, in many, many different places. So let me tell you about navigation system in Unreal 4. It consists of a couple simple parts. The first thing you need to do on the map to have nav mesh generated there, you just put nav mesh bound volumes. And the volumes pretty much define where the navigation is going to be generated. Simple. And then you have navigation relevant actors, which are things on the map that have some navigation relevancy. So they either have a collision shape or they define custom data like areas, which are basically saying, just annotate this nav mesh where I'm standing. Or of my shape, that can be a building as well. Areas are, just by the way, a lot faster to use than regular geometry. Or navigation links, which are, this is a little old school part of Recast, because like I said, it's not new. So if you have like jump down, vault over connections, you need to create them kind of manually. You can automate that, but those are still discrete connections between locations. A new approach would have like a full edges connecting, but still it works pretty well. And we allow actors to define those as well. And the last big part is navigation octree. we are using to efficiently query the space for actors or any navigation data, navigation relevant data in like specified location. Because like we all know, arc trees are good for querying space for like, give me all the stuff within this box or like this radius around the point. Excuse me. I'm nervous. I'm nervous every single time. Okay. So what's the problem? It works kind of, right? So this is the GDC demo map. It's big. So this naive approach, it just doesn't scale. This little piece here marked that's 16 square kilometers. The whole map is 256 square kilometers. So this approach doesn't scale to the point where navigation octree, treated in a naive way, takes 10 gigabytes on this map. So if you wanted to do that, that would be like you would need a lot of memory to be able to run it. Plus the navigation mesh itself, is generated all over the map, is 500 megabytes. Plus you need 30 minutes to generate the whole nav mesh on a map with all, which is another downside, with all levels loaded. That's a little drawback of our of the way we generate nav mesh now. It's on the list to change, but that's the current state. So this is obviously a big workflow no-no. It's like it never happens. Like no one loads all the maps just to generate nav mesh. It's just insane. And you would need that would take like 22 megabytes, gigabytes of everything. Like load all the levels, generate a nav tree. It's just no. Wait, no. This of course is useless. Useless. So why do we take that much memory? So empty nav mesh on the whole map. That's 10,000 tiles. Every tile takes more or less, like after generating, 50 kilobytes, which after changing nav mesh tile to these grade values, it's like 160 meters per 160 meters. It's like pretty big tiles. It's already, like it took 500 megabytes generated on the whole map. And we started off with a lot smaller tiles, like 16 meters per 16 meters. And there was 1 million tiles on the whole map. And that was the empty nav mesh with no actual data generated. That was already 170 megs. So that was, no, I refuse to accept that. Plus, the biggest offender is that most of the map, GDC demo map, is landscape. And those are huge chunks of geometry. Most of those 10 gigabytes in the navigation octree was actually pre-processed landscape data. Landscape is our solution for terrain modeling, if you didn't know. So yeah, sorry, I'm referring to landscape throughout all my talk. So that's what it is, our terrain solution, basically. So, okay, so let's figure out what should be the idea, like what should be the solution. The very first solution, let's just dump the expensive part, the navigation octree, and we just stay with the 500 megs static nav mesh, which is not ideal because we still need to load all the maps to be able to generate that. That could be done kind of offline or like overnight in an offline process while building everything every day. But we didn't want that because one of the goals was to have a dynamic nav mesh generation on the map as well, so that we don't take we don't make a huge use of it in the GDC demo, but the GDC demo ships with Unreal 4.8, and you will be able to just play the demo and while doing that spawn actors or stream levels in, and nav mesh will generate on those as well, like seamlessly, as if it was always there. That's the whole point of dynamic runtime nav mesh generation. Damn, it's pretty dry here. So another idea was to just build a special landscape dedicated navigation solution. Landscape is represented, like the representation of landscape is pretty straightforward. That would be really easy to generate a graph and figure out if connections are traversable and stuff like that. But and that would save most of the memory we're losing in navigation octree because, like I said, the landscape is taking the most 90%, 95% of it. But it's not a good idea neither because there's a lot more other stuff than just landscapes in the demo. There's a lot of pretty big static meshes, just scaled to insane proportions. I don't encourage that, but who can stop the artists? So they're doing crazy stuff, so we need to support that. The last idea I played around with was to just generate a really rough nav mesh through all the map. You could do that pretty easily, just having really huge voxels, like 3 meters per 3 meters. And that would generate pretty fast, wouldn't take too much memory. But the problem in this case is that you would need additional navigation solution when AI was following this rough high-level path. You would still need a kind of local steering or still generate nav mesh at runtime, which is like, why bother, right? You don't, like, it doesn't buy you really anything. So no worries, let's just see what we can do without too much hassle, because by that point we had like 2 months to go to GDC demo and 1 month for actual implementation. So what can we do? Like, common sense. Okay, so let's don't generate nav mesh just everywhere. We just need it only in a couple of places, right? And so if so, then maybe we don't need just everything in the octree, right? Duh, right? Obviously. So it's not rocket science. It's like step by step, you're just coming to those obvious conclusions. So I'm saving you time now. You'll come to these conclusions as well at some point. Well, probably sooner than me, but I came first. So applying this approach to UE4 navigation system is basically like we need to apply it to the 3 parts I described earlier. So navigation bounds stay the same. There's nothing we can do about it. One of the downsides of it is we are still paying recast cost of having like really big but empty nav mesh. But with those really big tiles I described earlier, it's not that big. It's like, I think it's 17 megs for a full empty nav mesh, empty nav mesh on a huge map, or maybe that's 2 megs, something like that. It's not that much. The next obvious step is, okay, so if we don't need everything in the navigation octree, then we just need to figure out a way to make sure the stuff that we don't need at the moment is not there. So we don't like occupy memory. And the last piece missing is we just need a way to tell navigation system that like where we need the nav mesh. If the nav mesh is not everywhere, then and we need it here, then we just need a way to be able to tell navigation system that, okay, put it there. So in terms of navigation octree, how to solve the problem with navigation octree, it's like obviously just like if you don't have to do it now, just do it when it's needed. So that's what we did. Basically, whenever something is being spawned or streamed in that we would need for nav mesh generation at some point, but not now, we just take another navigation octree takes a note of like this thing is being here, and we just have a rough bounds. But we're not gathering any geometry information, no navigation modifiers. That's one of the names we have, like for areas and links. And we actually generate that data, gather that data, when there's a tile being built that needs that data. And it's done at that time when we build that tile. And the tile asks navigation octree, okay, give me data that you have here, like for this box. And navigation octree says, wait, give me a second, like this guy didn't generate his data yet. Then it gathers the data and gets back to the tile building so that it just uses the data at that point. And one still, landscapes, that's a custom thing so that it works well, but we have custom problems with it. So still with the changes to the navigation octree so that we can gather data lazily, we still can't store the data of the landscape in a efficient way in a Vector. We would still have a lot of memory taken by it. So for landscapes, what we're doing is we're exporting very narrow, only the part that's needed. That's the part we're exporting. It's I would need to describe you how landscapes work to be able to, just so that you appreciate how important it is. Enough to say is that like this huge map, that's nine landscape actors kind of thing, and every actor is like 200, like hundreds of components. And even a single component, if we wanted to export the whole component, that would still take a lot of memory. So what we're doing, we're just taking a physics representation of the landscape and pre-processing it really efficiently, and we're just like doing it on the fly. We're not, with such a big tiles that we have, it proved not to be a problem. Like combined the tile size and efficiency of actually processing the physics data of landscape. So we're doing this on the fly. Again, that's being done at the moment when this data is required by a navigation tile that's in the process of being generated. And the way we tell navigation system where we need navmesh, that's actually like really simple. I've introduced a concept of navigation invoker, which is basically someone that invokes navmesh. And it's actually the easiest way to do it. I've created a navigation invoker component. You just apply this component to an actor, and it just works. And it has two values. There's internal and external radius. Internal radius is a radius that forces navigation tile to be generated whenever this tile is like within this internal radius from any invoker. And the external radius means like we're streaming, like not streaming out, we're just destroying any navigation tile that has been generated previously, but now is outside of any external radius of any navigation invoker. And it's like it's pretty straightforward. I've tested it with 300 invokers. I wasn't able to notice it in any performance runs I've run. And those invokers are being updated on a regular basis. You could do it every frame, but I think we're doing it like at 4 hertz, maybe. It doesn't really matter. And the way it's being done, like every invoker is, I'm processing all the invokers in sequence, and I'm just gathering information about the tiles we need active and the tiles we don't really need active. And it's like tiles we need active and tiles we want to get rid of. And by like processing all the invokers in sequence and modifying those two sets, I just come up with a list of tiles to release and new tiles to create. You have the same here, okay. And it's actually pretty efficient. Even later I'll show you a demo of deer running in the GDC demo. Maybe it's now. Yes, it's now. Excellent. So every deer is a navigation invoker, and by the way, this is like a specially created case. Like you can see, the tiles are a lot smaller than 160 meters, but you can see that the deer are running kind of in front of the camera, and in the direction they're running, the new navmesh tiles are being generated. That's basically the whole point of this feature. And under the hood, every deer is a navigation invoker. It has this component basically. So if you are able to separate one deer away from the herd, navmesh will generate in the direction he's running as well. Obviously, the radiuses, radii are configurable, and like you can do whatever you want with them. Nice. So, so after the GDC demo, at GDC, this is what we ended up with. Navigation Octree still takes half a gig. I'll explain why. But navmesh usually was taking around 30 megabytes at any point. And that's with a lot of deer running around, like with 3 or 4 herds at the horizon, every one of them being at least 30 characters, like characters, basically. So it's still not ideal. Half a gig for navigation octree is still a lot, right? But yeah, we're not done. I know exactly what to do to bring it down. And I'm going to tell you what exactly. Oh, damn, that was fast. So first of all, we are still storing a lot too much stuff in navigation octree. Currently, we got rid of geometry, but we are still storing all the additional information, like navigation modifiers information on navigation areas and links. Those things could be gathered dynamically as well. That's pretty smart. That's pretty easy to pull off. One of the licenses already did with our Recast integration is they were able to just have dynamic navmesh bounds in a way so that the player is running forward through potentially endless world. And the navmesh bounds are just kind of updating, and the tiles are building ahead of the player. But still, the whole navmesh is a fixed size. It's like 200 tiles, and that's it. Right? It's just reusing the tiles that are behind the player. And it's doable, mostly because Recast doesn't really care about where the tile is. He just cares about the number of tiles. So that's easily doable. Well, maybe not easily. It's not 5 minutes work, but doable. Another drawbacks of current approaches, once a thing is lazily gathered and added to navigation octree, it just stays there forever. So if you were able to play the GDC demo map and just fly through the whole map, you would end up with a lot bigger navigation octree. Still not 10 gigs, because we are not storing landscape information, but that would pile up. So the solution is to just have like any single thing you add to navigation octree, to give it a tag or like time life, also like limit, and just remove it after like configurable time. I think a minute would be 5 minutes, yeah, whatever. I mean, that would be tweaking, and it depends on the game, but that's one of the ways to handle it. And currently, this lazy gathering is being done on a single thread. It's outside the game thread, so it's not blocking anything, but it's still done in a single thread, because that was the easy way to implement that in this limited time frame for GDC demo. And yeah, I need to figure out a proper way of doing that so that we still get a bonus of doing it lazily outside of game thread and not use too much locks to just not hang ourselves with locking, because who doesn't love deadlocks? And that's basically it, but I could talk about it forever, so if you have any questions, either speak up now or send me an email or a tweet or come to talk to me. I'm at the booth all day. And you don't have mics, so you probably won't ask questions. I can give you mine.
No, on this demo with Deers, it shows that it creates new tiles and creates, but it removed them at some point, right? Or they just expand and expand.
So it doesn't show the tiles behind the herd. Do you hear me? That's fine? Okay, awesome. So the tiles that leave behind the herd, so that they get outside the external radii, navigation invokers, those are just removed at almost no cost. It's instant. Just one call on the Recast navmesh, just remove tile, gone. Basically, it doesn't even release it doesn't release some memory, but it's like instant cost. And yeah, they can run until the end of the map and then fall and die. Apart from that, they can't. And well, I haven't tried. Give it a try. Like keep them. No. Yeah. Can you pass over there was another question? Unless you want to follow up? No? No. Another question?
Okay, so this is a great approach for wildlife. Though if you want to send a deer to the other side of the map, there is no navmesh there. yet.
So
you can do it.
So if you currently no.
Okay.
However, you could do that if you would like. Well, first of all, that's a pre-game specific thing to be able to generate a path from the beginning of a huge map to the end of the huge map. You usually don't need that, and if you do, that's so game specific. Probably have extra systems like item graph or something that does that. But you could do it with this system as well, because you can create a, or maybe I even have it ready to use, but you can just create a custom agent that has this mission walking component. Just put them on the along the road kind of thing, and AI will be able to find a path with knowledge generated with those invokers. I know it's not ideal, but you could connect this solution with one of the solutions I described earlier, like this really rough high-level knowledge, and then find a high-level path on that knowledge, and then use this system to actually generate knowledge while AI is following this high-level path. That could be done. It's not supported out of the box, but there's a lot of things you can use to get this effect.
You're using a star? Yes.
So currently, the way we are finding paths, that's invoker's A star. It's pretty fast. One of the benefits, or one of the ways Recast works is it pre-bakes agent radius in the numbers, so that while looking for a path, we no longer care about radius. We're just looking for a path for a point, which is like we skip a lot of calculations. So yeah, it's A star. It's Recast A star. Yeah, maybe you wanted to ask about jump point pathfinding.
Yeah.
So with dynamic numbers, we can't really do that, because the jump point A star requires, or whatever is the official name of it, requires pre-baking some information. And you can't really do that. We tried that. For Fortnite, it's such a dynamic game. The numbers has been generated there like all the time. Like, every single second, there's a couple of tiles being generated, and it works, which is awesome. But we were looking at ways to improve pathfinding time, because there's a lot of AI doing pathfinding, and the tiles get invalidated, the paths get invalidated again, they need to find another path. Like, it's happening all the time. But it wasn't a valid choice, because we weren't able to pre-bake required information with the numbers. Any other questions, anyone? Any pass the mic? Thank you.
A few years ago, I tried to implement dynamic generation of navmesh, and and exactly there was the problem with the resources. I'm curious how much resources now your implementation of generation in dynamic it takes. For example, it takes, I don't know, one core. So
what you see here, I don't even actually remember. I mean, it all depends on the configuration of your game. There's a lot of things you can configure with our dynamic generation. We are generating stuff on multiple threads, so there is a limit still, but you could hard code it differently. I think by default it's like up to 1/4 of your cores. So we are using multiple threads. Obviously, there's a lot of either locking you need to do or memory copying. That's our approach. That's why, like, if a tile needs to generate, it asks navigation output for data, but it's copying this data so that it doesn't like try to read data that's being written from somewhere else, because that would be a crash, right? Or to get corrupt data. So memory is a bigger problem, not CPU. Although if you're running knowledge generation on a dedicated server, then CPU is a bigger problem. But we, again, Fortnite is running on dedicated servers, and this didn't. This is not a red flag yet. Yeah. Fingers crossed.
So, implementing it on the console is not a problem.
Yeah, not at all. It just runs. I mean, there's a lot of parameters you can tweak. If you see navmesh generation showing up in your performance profiles in some way, you may maybe need a bigger boxes, for example. That's the easiest way to speed up navmesh generation. Or maybe bigger tiles, because the bigger the tile, the longer it takes to generate it, but you you don't pay extra cost for overhead while generating every single extra time, right? What else? You can always consider using static numbers, which is generated offline, but then the front end is almost free. Almost. It just takes memory and pay CPU processor for pipeline. Any other questions? One? The question may be in Polish. No problem. No? You look like someone that would have a question, no? Almost like a question like?
You're talking to me?
Yes.
I have a question. How much threads do you have, how much cores do you have on the dedicated servers for Fortnite?
So the problem with dedicated servers is you get one core. So in Fortnite, actually, we are doing all of it in a game thread. That's why it's so surprising it works. But so yeah, like I said, Fortnite is a specific game. It's super dynamic, and extra restriction is we are running it on dedicated servers. So if you want a game with AI and runtime numbers generation and dedicated servers, this is really well tested on our end.
Is it already 4.8?
Which part? This thing?
Yeah.
Yeah, it is. Although it might be broken. No, I mean, I tested it a week ago and it was fine. I tried to grab a screenshot an hour ago and it wasn't. So I need to figure out what's wrong. Worst case scenario, it will be working again in 4.8.1. But yeah, I need to check, so don't talk about that and it's being recorded as well. Yes. Any other questions, or you want something else? These guys.
Is there a way to mix up those two approaches? For example, we've got an island, so open space, landscape with this kind of navigation, and on it there is a house, hut, factory, or something like that. And inside the building, I think there should be the other kind of this static. Is there a way to combine this somehow?
In the background. I know it's needed. One of the things that's still not working as well as I'd like is, for example, static numbers streaming as well. That's yet another thing people need. So that you build numbers on many levels people are working on separately, and then when you stream it in and just like stitch it together and works. This doesn't work for yet neither. That's why I encourage people to use random number generation, because that's the thing we use the most, and it's just working. Simple as that. Just use it anyway. It's cheap and fast. Yeah, it's good.
No pesos.
And no pesos. Until you earn pesos, then share something. It's not you paying us, we're just sharing. And it's true, right? No, just look at it. It's like, we want money only when you have money. It's like taxes. It's not a good thing. It's not taxes. Hey, you have a question? So, you mean the yard running smoothly or not? So this smoothing you see with here is being done on Pon's movement, in Pon's movement components. So that we make sure those like four-legged creatures don't turn in place like human. It's in the movement component. Like you need to handle it yourself. I want to make it an engine feature, but it's yet another thing on the list. There are any other AI programmers I don't know. But they're very really high. So, yeah, and one of the problems with the guy that was making the early demo, who was working on it, is that those guys are using Detour Crowd, which is a recast solution for crowd simulation, which is it's complicated, but it's hard to work. We will be writing our own avoidance solution, not too far in the future, but you can use this yourself, but be ready to do some tweaking. Because the setup out of the box is pretty expensive. It's academic. It's not really suitable for games until you do that. One. anything else you want to know?